Hi guys, welcome back. So today we are going to continue to simplify radical expressions, and then for fun we'll simplify some expressions involving rational we will simplify some expressions involving rational exponents, and this is round 1, so I guess if there's a round 1 there has to be a round 2. So let's do this. Some of these problems you have to be very careful in terms of how the answer is expected to be written. It may say write your answer in radical form or exponential form. If you are asked to write your answer in radical form, that's code for and I better see a radical or else. If you are asked to write your answer in exponential form, that's code for there better be an exponent in your answer. Okay, so let's go ahead and do this. So it says exponential form of this bad boy. Okay, so the question is, how can I write it without the radical, or how can I get out of the radical? You can read it, but I'm gonna go ahead and write it right here with you. Okay, we have nth root of b to the m. Okay, how can I write it without the radical? So this is how it's gonna go down. You're gonna keep the base. Okay, so we're gonna write it as b, and then we want to write it raised to some power. How do we write that power? You're going to keep that current exponent of m, and then you're going to divide by something. Okay, you're going to divide by whatever the index is. So the question is, oh, do I have to memorize nth root of b to the m equals b to the m over n? Like, no. Well, I guess kind of, yeah. Okay, but for me, I don't remember it like a formula, you know, nth root of b to the m equals b to the m over n. I don't. Okay, the way I remember it is like, okay, how do I write it without the radical? I'm like, oh, okay, I'm going to keep the base, and then I got to write the exponent as a fraction. How do I do that? Oh, it's current exponent divided by the index. So notice how I didn't make a reference to the letter b, m, or n. I say it in words because that's how I remember it. But now the question is, how do we backtrack it? You know, how do we backtrack it to radical form? So if I have something like this with the exponent, okay, how do I backtrack it? I know you can read it, but I want to write it with you. Okay, so we have b raised to the m over n. Okay, so I'm going to share a secret with you. Whenever you have a rational exponent, you know, English, whenever your exponent is a fraction, whenever you have a rational exponent, that is code for hidden radical. And this is how it's going to go down. You're going to start with the denominator. I mean, start with whatever you want, but this is how I remember. This is how I remember it. You're going to start with the denominator. Since the denominator is n, then that's going to be your index. So that's going to be code for nth root of what? Nth root of whatever you're left with. So you can't read my mind, so I cover up that denominator, and that leaves us with b to the m. Okay, so if you want to backtrack it to radical form, just remember a rational exponent is just code for hidden radical. You start with the denominator, and that will be your index. So in this case, it's the nth root of whatever you're left with. Okay, so that's it. I'm going to take it a step further, which you may not appreciate now, but hopefully in a later video I will explain why. Okay, if you wanted to write it more, what you can do, you can write you can take the exponent out of the radical. So we can just write it as nth root of b, and then we'll raise it to we'll raise the whole radical to the nth power. Okay, so whether you leave the power inside or outside the radical, you know, you get the same thing. Okay, that was fun. Okay, so that's too many words. Let's go ahead, get these things put it into practice. So the directions read: find the product or simplify the expression as indicated. Assume all variables represent positive real numbers, and write your answers in radical form if necessary. I want to make a big fuss about that second sentence. Assume all variables represent positive real numbers. And I'm not gonna lie, these are my favorite words to hear when it comes to radicals. The reason being is this: from an earlier video we were talking about, like, say, square root of something. Sometimes we had an absolute value in our answer, and sometimes we didn't. So we had said that the absolute value was required for even roots to ensure that our radicand is positive. But in this case, if you're told that every variable represents a positive real number, then we don't have to worry about do we need an absolute value in here. Okay, I've said too much. All right, let's do this. So we have square root of w to the 50th power. Okay, so we have 1, 2, 3. I don't know how to count. It's through F. Okay, A through F. I don't know how to count. Actually, I don't even know how many letters we have. Okay, so let's do this. So we have square root of w to the 50th. So I was like, man, I wish I was on it, but I'm really not because I'm tired. Okay, so again, memorize what you have to, digest as much as you can. Let's go ahead, use that rule to get this into exponential form. So let me go ahead, remind ourselves. If we have nth root of b to the m, how can I get out of the radical or put it into exponential form? So we're going to start with the base and write the exponent as a fraction. Okay, it's going to be current exponent divided by the index. Current exponent divided by the index. Okay, so let's do this. We want to get out of the radical, so we're going to take that base of w and write that exponent as a fraction. So it's going to be current exponent divided by the index. So I'm like, oh man, like, well, what is that index? So remember, if a number is not written in that nook, then that index is 2. Okay, if you want to pencil it with me, go for it. If you don't need it, then I don't need it. Okay, so in this case, this is why we read it as square root. Okay, so in this case, we're going to write the square root of w to the 50 as base raised to the current exponent divided by the index. And this is how we're going to simplify the radical. We're just going to divide. If it gives us an integer, then we write that integer exponent. And if it doesn't give you as an integer, then we'll highlight the quotient and the remainder. But lucky for us, quotient of 50 and 2 gives us a clean number of 25. And now the question I ask myself is this: well, what's my answer? That's it. That's the actual answer. Okay, so the moral of this story is that the square root of w to the 50th simplifies to w to the 25th. If you wanted to check it, how can we check it? Our answer raised to that index needs to give us back that radicand, and it does. Okay, problem B. Let's do this. Okay, problem B, we have cube root of x to the 60th power. Okay, so if you just know the answer off the top of your head because you see it, more power to you, but I really can't. Okay, so what am I gonna do? I'm sorry, what am I gonna do? I'm gonna write this in exponential form. In English, get it out of the radical. So we're gonna start with the base of x and write that exponent as a fraction. And to do it, it's current exponent divided by the index. Current exponent divided by the index. If the fraction gives us a clean number, cool. And if it doesn't, we'll highlight the quotient and the remainder. But in this case, lucky for us, quotient of 60 and 3 will give us 20. And that will be your answer. If you wanted to check it, you take your answer, raise it to whatever that index is, and that should give you the radicand. Alright, problem C. We have cube root of m to the 23rd power. Okay, I know you're a genius, but I'm not. So let me go ahead and show some work. Okay, so I'm like, okay, what is the cube root of m to the 23rd? I really don't know. So what am I going to do? I'm going to write it in exponential form, or in English, get it out of the radical. So to do this, we're going to start with the base and write that exponent as a fraction. So it'll be current exponent divided by the index. Okay, I'm running out of space, so I'll use the computer syntax notation. So again, if that fraction gives us a clean number or an integer, cool. And if it doesn't, highlight the quotient and the remainder. But unfortunately, quotient of 23 and 3 doesn't give us a clean number. And I'm a little too tired to do this in my head. So let me show some work. And I guess it's going to be 7 remainder 2. So let's go ahead and write that old school answer. Okay, so that's going to give us m raised to the 7 Remainder 2. Don't get me like all excited with your decimal answers. No, we have no time for that. Now the question is, how can I tell if I'm going to write my answer as a radical? Well, if you get a clean exponent, then you're good. But if you have like a remainder, no. Okay, so this is how it's going to go down. Since the quotient is 7, we're going to tell the reader that 7 factors of m are going to come outside the radical. If you have a remainder, then that's going to tell the reader how many of those factors are left inside the radical. Since the remainder is 2, that means that we're going to be left with 2 factors of m inside the radical. Okay, now in this case, if you have a leftover radical, it is important that you preserve that original index, okay, unless you can simplify it further. So we're going to tell the world cube root of m to the 23rd power simplifies to m to the 7th times cube root of m squared. So that's my answer, and I'm sticking to it. Alright, let's go ahead and knock out problem D. Problem D, where am I? Okay, so we have 4th root of y raised to the 31st power. 4th root of y raised to the 31st power. So if you're on it and you just know the answer, go for it, but I really don't. Okay, so let's go ahead and put this in exponential form. So we're going to keep the base of y and write that exponent as a fraction. It's going to be current exponent divided by the index. Current exponent divided by the index. So let's go ahead, simplify, and highlight the quotient and remainder. Again, I'm too tired to do this in my head, so I'm going to bust this out in a thinking area. 4 goes into 31, I think at most 7 times with the remainder 3. So let's do this. Let's highlight that quotient and that remainder. So that will give us y raised to the 7 remainder 3. Does this look funny? Of course it does. Okay. When we have a remainder, that is code for leftover radical. So once again, the quotient is 7. So 7 factors of y are going to come out. We got a remainder. The remainder is 3. That means that 3 of these guys are going to stay in. And then what was that index? Index is 4. So make sure that you bring down the 4. Because we're not going to go from 4th root to square root just for fun. Unless we can simplify it to that. Okay, I think I did these problems out of order. Or I had a new game plan. I will never know. Give me a sec. Okay, so let's go ahead and continue with this fun problem. So we have x raised to the 3/10 multiplied by x raised to the 2/10. So at a first glance, I kind of feel like this problem is out of place because the first 1, 2, 3, 4 problems, you know, we were working with radical expressions, and this one is not a radical. It's not a radical expression. It's a rational exponent. It's a rational expression. It's an expression. It's an expression with rational exponents. Yeah, I need a break. Okay, but I did say in the beginning that we will be simplifying expressions, radical expressions, and then we will also be simplifying expressions with rational exponents. So it's an expression with the rational exponent. So I didn't lie to you. Okay, so in this case we have two things separated by a multiplication sign. So I guess we have to multiply. So I'm like, oh, x to this fraction times x to this fraction. So I'm multiplying two things that have the same base. And then I'm like, okay, what am I gonna do? I'm gonna copy what I did from an earlier video when we talked about the exponent rules. So I'm like, oh, I'm so frustrated because I forget silly exponent rules. They make me so mad. And if you don't say it like that, then it's not gonna work out. Okay, so when we vent out our frustrations, we're gonna remind ourselves that whenever we have a multiplication problem, meaning we're multiplying two things that have the same base, we're gonna keep the base and add the exponents. Okay, keep the base and add the exponents. So we're gonna keep the base of x and then add the exponents. So 3/10 plus 2/10. Under normal circumstances, I could totally add this in my head, but I don't want to risk it because when you're tired, you make silly mistakes. Sometimes you forget your name. We keep our cool. Lucky for us, the denominators are the same, so we have green light to proceed. So the sum of 3/10 and 2/10 will give us 5/10. And last time I checked, 5/10 reduces to 1/2. Okay, so the answer is x raised to the 1/2, and that is the correct answer. Okay, the answer is correct. Unfortunately, it's not accepted for full credit because we are asked to write the answers in radical simplified form if necessary. So pretty much, if you can write your answer with the radical, go for it. Now, we didn't start out with the radical expression from the beginning, but check it out. Remember, whenever you have a rational exponent, that is code for hidden radical. So in this case, we're going to start out with the denominator. Since the denominator is 2, then that is code for we got the square root of something. Okay, so whatever the denominator is, that's going to become the index of your radical expression. So it's going to give a square root of whatever we're left with, and in this case it's going to leave us square root of x to the first power. But then we're going to clean this up because we want our answers to be as beautiful as possible. When the index is 2, it's not really needed, so I would appreciate it if you omit it. Okay, and then when the exponent is 1, again, it's not really needed, so I would prefer to see square root of x. Fantastic. So let's go ahead and knock out our I don't even know how to count, but it's letter F. Whatever number that is our problem. I think that's 6. Okay, so F, where am I? We have 4th root of x times 5th root of x squared. 4th root of x times 5th root of x squared. So for me, what I'm tempted to do is to multiply the radicands right now. But the reason why I cannot do that is because the indexes are not the same. So I'm like, man, I'm stuck. Okay, so what am I gonna do? I'm just gonna get out of the radical or fancy math, write it in exponential form, and then take it from there. So let's do this. So to put it in exponential form, we're gonna keep the base, which is x, and then we're gonna write the exponent as a fraction. So how are we gonna do that? We're gonna take the current exponent and divide it by the index. So current exponent is 1, index is 4, so we're gonna tell the world that the 4th root of x is just the same as x to the 1/4. Okay, now what are we gonna do with that? We have a raised dot, so we're gonna multiply it by what? By 5th root of x squared. Okay, so let's get it out of the radical, or in math, put it in exponential form. So we're gonna keep the base and write the exponent as a fraction. So to do that, current exponent divided by the index. Current exponent divided by the index. So what am I gonna do right now? So I'm like, oh man, what's going on? Oh look, we're multiplying two things that have the same base. Oh, you know what time it is? Time to write in my journal. Okay, time to vent out my frustrations. Silly exponent rules, they make me so mad. So then I'm gonna remind myself that whenever we have a multiplication problem, meaning we're multiplying two things that have the same base, we're gonna keep the base at the exponents. Do you have to be mad? You don't have to be mad. You just have to get it right. Okay, I'm trying to give you like a way out. Okay, so if we have a multiplication problem, we're gonna keep the base and add the exponent. So we have 1/4. We keep the base of x and then we add the exponents. So who can add a 4th and 2/5 at the top of their head? I sure can. So let me go ahead and show some work. So in this case, the least common denominator between 4 and 5 is 20. So let's go ahead and write those equivalent fractions. So that will give us, let me squeeze in a times 5. We're going to tell the world that 1/4 is the same as 5/20ths. And then we will tell the world that 2/5 is the same as 8/20ths. Or 8/20. Okay, thanks to our hard work, now that we have those equivalent fractions, let's go ahead add them up. Okay, so we're gonna keep we're gonna add the numerators, namely 5 and 8, to get 13, and then write that sum over the common denominator. So this is it. This is the answer. Okay, it is correct. The reason why it's not accepted for full credit is because we were told explicitly to write the answer in radical simplified form if necessary, or if possible, sorry. So pretty much, if you can give me a radical, cool, and if you can't, then don't. But whenever you have a rational exponent, that is code for hidden radical. So let's do this. So we're going to go ahead start out with the denominator because that will give us the index. Since the denominator is 20, then that's going to give us that the index is 20. So it'll be the 20th root of something. 20th root of whatever we're left with, and that will leave us with x to the 13th power. Fantastic. Okay guys, so I think I had said we were gonna go to problem F. That is F, so we're good to go. Thanks. Stay tuned though, okay?